Hello everyone, I am Srivani, online tutor. I have been teaching maths, physics and chemistry to thousands of students for more than 15 years now. I focus on various curriculum. Currently, the CBSE has announced MCQ pattern for the board students. Yes, this is a new format. But children, all of you can score good. The only thing you need to do is make sure your concepts are strong. And secondly, with subjects like maths and science, you need to have a smart approach in handling the different models of questions. So in my channel, I will be focusing on the objective part with the boards as well as the entrance. Let's get started. Hello everyone. Let's do a continuity and differentiability chapter, MCQs. And these MCQs are from Exemplar book, NCERT Exemplar. And this is important for CBSE boards, term 1 exams now, and also for the entrance. The first question. So the question says, if f of x equals 2x, g of x equals x squared by 2 plus 1, then which of the following can be discontinuous function? So let's check the options one by one. The first option, option A, f of x plus g of x. So this is going to be 2x plus x squared by 2 plus 1. So looking into it, it is a quadratic polynomial. So we know this polynomial function is definitely continuous for all x belongs to R, the real number set. The second B option, the question says f of x minus g of x. So f of x is 2x, g of x is x squared by 2 minus 1. Again, this is a quadratic polynomial and we know it is continuous for all x belongs to the real number set. Option C. Option C is f of x multiplied with g of x. So f of x is 2x multiplied with x squared by 2 plus 1. So this is going to be 2 cancel. It's going to be x cube plus 2x. So this is again a cubic polynomial. Again it is continuous for all x belongs to real number set. Option D. Option D is g of x divided by f of x. So what is my g of x? X squared by 2 plus 1 divided by 2x. So when I take LCM, I will be having x squared plus 2 divided by 4x. So now let's look at the denominator. Denominator is there, having x in the denominator. So which means this function is continuous, but when x is equal to 0, what happens to the denominator? The denominator will be 0. It's going to be 0 square plus 2 by 4 multiplied by 0. So it is 2 divided by 0. So 2 divided by 0, anything divided by 0 is undefined and it is definitely discontinuous. So the function is discontinuous at the point x is equal to 0. So the correct option is option D. So moving on to the next question. The question says f of x equals 4 minus x squared divided by 4x minus x cube. So let me take the factors of the denominator. So I have x multiplied with 4 minus x squared. So the question says there are 4 options. Discontinuous at only 1 point, 2 point, 3 points and none of these are the options. So let's, for a function to be continuous, what is the condition for a function to be continuous? A function is continuous if f of a equals limit extending to a f of x. Okay, so here when I look into the factors of the denominator, x square 4 minus x square. So let me take, I have x square minus 4 equals 0. I have x square equals 4, which means x is equal to plus 2 and minus 2. So let me take x limit extending to 2 f of x. So this will be extending to 2. The function is 4 minus x square by x multiplied with 4 minus x square. Now here when I substitute the value of x is equal to 2 here in the numerator, 4 minus x square. So it is 4 minus 2 square, which is 4. So the numerator is 0. Denominator again, when I substitute x value to be 2, I have 4 minus 4 again 0. So it is 0 by 0, which is indeterminate form. So it is discontinuous at the point x is equal to 2. So the function is discontinuous at the point x is equal to 2. Now limit x tending to minus 2. Let me check for minus 2 value, f of x. So limit x tending to minus 2, the function is 4 minus x square divided by x multiplied with 4 minus x square. So here again, when I substitute x value to be minus 2, here it is x square. So minus 2 square is again 4. So numerator 4 minus 4 will be 0. Denominator also 0. Again I get the indeterminate form. So the function is discontinuous at x is equal to minus 2. Now when I substitute the value 0, I have x multiplied with 4 minus x square in the denominator. If I substitute, if limit x tending to 0, f of x, limit x tending to 0, the function is 4 minus x square by x into 4 minus x square. So here 4 minus x square and 4 minus x square is getting cancelled. So which is limit x tending to 0, 4 by x, not 4. 4 minus x square got cancelled. So I will have 1 by x. So again, if I put the value 0 here, the denominator, it will be 1 by 0. This is going to be 1 by 0. This is undefined. So again, the function is discontinuous at the point x is equal to 0. So the function is actually discontinuous at the point x is equal to 2, x is equal to minus 2, and also x is equal to 3. So it is discontinuous at exactly 3 points. Moving on to the third question. The question says the function f of x is cot x is discontinuous on the set. Okay. Now the function, given function is cot x. Cot x can be written as cos x divided by sin x. Cos x is a trigonometry function, sin x is a trigonometry function, they are continuous. Now let's look at the sin x, the denominator sin x graph. So when we look at the graph of sin x, this is the sin x graph. So this sin x graph is having 0 between 0, 1 and minus 1. So at the integral values of pi, 2 pi, here minus pi, minus 2 pi, sin x is giving a 0 value at the integral multiples of pi to pi. Sin 0 is 0, sin pi is also 0, sin 2 pi is also 0, minus pi is 0, minus 2 pi is 0. So integral multiples of pi, the denominator sin x is giving a 0 value. So in this function, when we have cos x by sin x and sin x is giving a 0 value, it becomes undefined. So which means again, the function is discontinuous at the values of x is equal to 0, x is equal to pi, 2 pi and all that, which is nothing but x is equal to integral multiples of pi where n belongs to integer set. N belongs to integer set. So in this set, the function is definitely discontinuous because the denominator sin x becomes 0 and the function cot x is undefined. So integral multiples of pi. Now moving on to the next question number 4. The question says f of x is e power mod x. And the options are continuous everywhere but not differentiable at x is equal to 0, continuous and differentiable everywhere, not continuous, none of these. Okay, so now for checking for continuity, so it says e power mod x. So x is having both positive and negative values. So f of x is going to be equal to e power plus x for all x greater than or equal to 0, e power minus x when x is taking the values less than 0. So we have this function. So to check for the continuity, you need to check for f of 0, which should be equal to left hand limit, which should also be equal to the right hand limit. What is my f of 0? F of 0 is e power 0, which is 1. Left hand limit. Limit extending to 0 minus f of x. Limit extending to 0 minus the function is e power minus x, which is going to be e power minus 0, which is 1 again. My right hand limit. Limit extending to 0 plus f of x. Limit extending to 0 plus the function 0 plus positive function is e power x, which is e power 0, which is 1 again. So when I look at the answers, f of 0 is 1, left hand limit is 1, right hand limit is also 1. So which means the function is continuous. The function is continuous everywhere. Now I need to check for the differentiability. Okay, so what is my f dash of x? F dash of x, I have my f of x. F of x is e power x and e power minus x. So for e power x, when I differentiate e power x, I get e power x itself for all values x greater than or equal to 0. When I differentiate e power minus x, it is going to be again e power minus x, and minus x when you differentiate will be minus 1 with respect to x. So it will be minus e power minus x for all x values less than 0. So now again checking for differentiability, let's go to the left hand, let's do the left hand limit and the right hand limit. So left hand limit. Limit x tending to 0 minus f of x. So which is limit x tending to 0 minus e power minus x. So when I substitute the value e power 0, e power minus 0, but I have a minus sign before e power minus x, so it becomes minus 1. Now my right hand limit. Limit x tending to 0 plus f of x, which is limit x tending to 0 plus e power x. So e power 0 is 1, so it is going to be 1 itself. So when I see the answers of the left hand limit and the right hand limit, they are not equal. So which means the function is not differentiable. Not differentiable at x is equal to 0. So it is option A. Continuous everywhere but not differentiable at x is equal to 0. So moving on to question number 5. Question number 5. The question says, if f of x equals mx plus 1, where x is less than or equal to pi by 2, and sin x plus n if x is greater than pi by 2. So this function is continuous at x is equal to pi by 2. Then there are 4 options. The relation connecting m and n options are given there. So the function is continuous. So we know when a function is continuous, we know that it is continuous at the point x is equal to pi by 2. So we know that f of pi by 2 is definitely equal to limit x tending to pi by 2 minus f of x, that is the left hand limit, which is also equal to limit x tending to pi by 2 plus f of x, which would be the right hand limit. So f of pi by 2 should be equal to the left hand limit, should be equal to the right hand limit, because the question says the function is continuous. So what is my f of pi by 2? F of pi by 2 will be m. So we need to see here x value pi by 2. X value is equal to pi by 2 means it is mx plus 1. So when you consider mx plus 1, this is going to be m pi by 2 plus 1. My left hand limit. Left hand limit is limit x tending to pi by 2 minus f of x. So which will be limit x tending to pi by 2 minus less than pi by 2. It is the function is the values of x less than pi by 2, the function is mx plus 1. It is mx plus 1. So I'll put it here, mx plus 1. Now I need to substitute the values. So it's going to be m pi by 2 plus 1 again. I'll write it here. Now my right hand limit. Right hand limit is limit x tending to pi by 2 plus f of x. Pi by 2 plus means greater than pi by 2 value. Greater than pi by 2 value, x greater than pi by 2 value, the function is sin x plus n. Limit x pi by 2 plus will be, the function is sin x plus n. So when I substitute the value of x to be pi by 2, I get sin pi by 2 plus n. Sin pi by 2 is sin 90. The value is 1 plus n. So now I have the values. My left hand limit is m pi by 2 plus 1. My right hand limit is 1 plus n. And f of pi by 2 is m pi by 2 plus 1. I can equate it and find the relation connecting m and n. So because the function says it is continuous. So all f of pi by 2, left hand limit, right hand limit, all three are equal. So m pi by 2 plus 1 is equal to n plus 1. So n is going to be equal to m pi by 2. 1 will get cancelled. So n is equal to m pi by 2. Option C is the correct answer. Moving on to the next question. Question number 6. So the question says, let f of x equals sin mod of sin x. Then the function is everywhere differentiable. Function is everywhere continuous but not differentiable at x is equal to n pi. Function is everywhere continuous but not differentiable at x is equal to 2n plus 1 pi by 2. None of these. So we know the function sin x. Sin x is continuous, but this is mod of sin x. You have to check for continuity as well as for differentiability. So let me draw the graph. Mod of sin x graph. So sin x graph will be like this. The x values. The question is not sin x. The question is mod of sin x graph. So this negative values. The negative graph is not there. So the negative will also be positive because it is mod. So the mod of sin x graph will be like this. So this is the graph of mod of sin x. So in this graph, when we look at the graph, we know for sure this graph is definitely continuous everywhere. The graph is definitely continuous. It's completely continuous for all values. It's continuous. It's completely continuous. Okay, it's continuous everywhere. But what about differentiability? When we look at the graph, and if the graph is having sharp bends, then we say the graph is not differentiable at those points. Okay, so or you take the values of, when we consider the values of sin 0, sin pi, sin 2 pi, minus pi, and minus 2 pi, at all these points, it is giving a value of 0. And there are sharp bends, so which means the graph is not smooth. So definitely the graph is not differentiable. Not differentiable at points at x is equal to 0, pi, 2 pi, or minus pi, minus 2 pi. So x is equal to integral multiples of pi, where n belongs to integers. So it is option B is the correct answer. So moving on to the next question. So the question says y equals log of 1 minus x square by 1 plus x square. Then dy by dx is asked in the question. So we need to differentiate here. So we have the formula, logarithmic formula, log of a by b is log a minus log b. So now y equals log of 1 minus x square minus log of 1 plus x square. Now I need to find dy by dx for this. So log, I have log of 1 minus x square. So log x, differentiation of log x is 1 by x. So log of 1 minus x square will be 1 by 1 minus x square. Again, I need to differentiate 1 minus x square. When I differentiate 1 minus x square, I will be getting a minus 2x. Minus 2x. Now here, log of 1 plus x square. So again, when I should differentiate log x, it is 1 by x. So it is going to be 1 by 1 plus x square. When I differentiate 1 plus x square, I will be getting 2x. So the numerator will be 2x. So when I look here, I have the terms minus 2x by 1 minus x square, again minus 2x by 1 plus x square. So minus 2x is common, which I can take it out. And inside the bracket, I will have 1 by 1 minus x square plus 1 by 1 plus x square. Now I can take LCM inside. So minus 2x. When I take LCM, it's going to be 1 plus x square plus 1 minus x square divided by, my LCM is 1 minus x square multiplied with 1 plus x square. So here minus x square plus x square will get cancelled. So I will have dy by dx to be minus 2x multiplied with 2 divided by 1 minus x square into 1 plus x square. So dy by dx is going to be minus 4x divided by, the denominator is 1 minus x square into 1 plus x square, which is a minus b into a plus b. So it's going to be a square minus b square. So it will be 1 minus x power 4. So this is my final answer, which is there in option B. Option B is the correct answer. Moving on to the next question. The question says y equals square root of sin x plus y. And I have to find dy by dx for this. So the easy way to do is taking squaring on both sides. Squaring on both sides. So when I do the squaring on both sides, y will be y square, and the right hand side, the square root and the square will get cancelled. So I will have sin x plus y. Now I will differentiate. So it's going to be 2y dy by dx equals sin x. When I differentiate, I get cos x, and y, when I differentiate y with respect to x, it's going to be dy by dx. So I'll bring dy by dx terms all to the left hand side. So it will be 2y dy by dx minus dy by dx equals cos x. So dy by dx is common, taken out. So 2y minus 1 equals cos x. So my dy, because the question asked is dy by dx. So dy by dx is cos x divided by 2y minus 1. Cos x divided by 2y minus 1. So it is option A. Option A is the correct answer. Moving on to the next question. The question says the derivative of cos inverse of 2x square minus 1 with respect to cos inverse x is the question. So let y be equal to cos inverse of 2x square minus 1. So dy by dx will be minus 1. So cos inverse x differentiation is minus 1. The formula is minus 1 divided by root of minus 1 minus x square. So here it is root of 1 minus 2x square minus 1 the whole square. So I have in the denominator a minus b the whole square. I have to expand this now. So what do I get when I expand? 1 minus 2x square. 2x square the whole square will be 4x power 4. 1 square will be 1. And then I have minus, so it will be, the sign is minus outside. So it will be minus 1 and plus 4x square. So now this plus 1 and minus 1 is getting cancelled here. So now I have my dy by dx equals minus 1 divided by square root of 4x square minus 4x power 4. So dy by dx will be minus 1 divided by 4x square. I can take it out of the root, which will be 2x out of the root. So it's going to be 2x 1 minus x square. So my z is the second function, cos inverse x. So what is dz by dx? So that will be minus 1 divided by root of 1 minus x square. So that's a formula itself. The question is the derivative of cos inverse of 2x square minus 1 with respect to cos inverse x. So I need to do dy by dz, which will be dy by dx divided by dz by dx. So here dy by dx, I again need to differentiate the function inside the square root. So when I differentiate again inside, I will be getting here 4x. So I will get a 4x in the numerator. So it will be a minus 4x. Okay. So now when I cancel this, I have my dy by dx to be minus 2 divided by square root of 1 minus x square. Dz by dx is minus 1 divided by square root of 1 minus x square. So these get cancelled, minus sign also gets cancelled. And my final answer is the dy by dz. My final answer is going to be plus 2. So option A is the correct answer. So moving on to the next question. Question number 10. The question says x equals t square, y equals t power 3. D square y by dx square is asked in the question. So what is my dx by dt here? It's going to be 2t. dy by dt, 3t square. Okay, so what is dy by dx? dy by dx is 3t square divided by 2t, which is 3 by 2t. Now I should find d by dt of dy by dx. What is my d by dt of dy by dx? I need to differentiate dy by dx, which is 3 by 2t, with respect to t. So when I differentiate it with respect to t, I will be getting 3 by 2 into 1. Differentiating t with respect to t is 1. So I get 3 by 2. Now my question is d square y by dx square, which is equal to d by dt of dy by dx divided by dx by dt divided by dx by dt. So d by dt of, what is my d by dt of dy by dx? I already found the answer for it, which is 3 by 2. Just 3 by 2 here. I already have this 3 by 2 here. Divided by dx by dt. Dx by dt is 2t. I'll put it here. So the answer is 3 by 4t. The answer is 3 by 4t is the answer, which is option B is the correct answer. So we have completed the objective questions of continuity and differentiability for today. If you like the video, you could watch more on my channel.